I don't know why.
Okay, guys. Notes from yesterday. They say notes, second fundamental theorem, part 2. Okay, we learned the chain rule yesterday. Okay, so let's briefly review before we start. Okay, your derivative, remember we already had plugged into the number 1. So when we plugged in the number 1 to the 2x, what did we get for the top of the integral?
2.
A 2, because 1 times 2 is 2. Then when we took the derivative, we had to do chain rule. So look up here at the top. Okay, chain rule says that I'm going to take the 2x, I'm going to still plug it in, but then I have to times by 2. Then, when I take the second derivative, what's the derivative of f? F prime, still of 2x, but then I have to times by another 2. That gives me a 4 in the front. Make sense? Okay, so now we're going to do it for negative 2. So, regular g, we're plugging into the 2x here. So what is negative 2 if I plug it in times 2x? 0 to negative 4. Okay, then look at your graph. 0 to negative 4, when I shade it, okay, I get this whole big shape. Question, yes or no, is that a trapezoid? No, trapezoids have to be parallel. So it is a trapezoid in combination with a triangle. Okay, so I cannot do that as one big trapezoid. Trapezoid bases have to be parallel. So let's run the yellow area first, 1/2. How long is the short base right here? 3. So this one is 3. How long is this one? So it would be 1/2, 3 plus 2, multiplied by the height of 3. So 3 plus 2 is 5, times 3 is 15, cut it in half is 7.5. Oh wait, we have to add the other one too. Okay, then this triangle, area, 1/2 base times height. My base is a 1, my height is a 2. 1/2, 1 times 2 is 1, so add 7.5 and 1 together, what do I get? 8.5. Now the area is below, so it's negative 8.5. Backwards. So even though this area is below, because this is backwards, my 8.5 is actually positive. Good? Okay. So that should be sort of review. Okay, g prime, I'm plugging into this. So g prime of negative 2 is going to be 2 multiplied by regular f at negative 2x. If I plug a negative 2 into 2x, what do I get in the middle? Negative 4. So I'm actually going to be looking for the y value at negative 4, then I'll multiply it by 2, which is negative 4 here. My y value is negative 3 multiplied by 2 is negative 6. Good? Okay, next one. I want g double prime at negative 2. Okay, so g double prime, I'm plugging into this one. I'll have 4 times g prime of, if I put a negative 2 in there, what do I still have in the middle? Negative 4. And then if I'm looking for f prime, that would be the slope of the graph at negative 4. Negative 4 is this little line segment right here. What's the slope of that? Yep, up 1 over 1, 2, 3. So that would be 4 times the third, which is 4/3. Good so far? Yes. 4 is an endpoint, so it doesn't really count as a corner. Technically, on the AP test, they probably wouldn't ask you the slope at endpoint. But, yeah. Okay, good? Okay, go to part C. Okay, this is where it gets a little tricky. I need you to all the way pay attention or it's going to get really confusing. Okay, so the critical numbers are when g prime is equal to 0, right? And g prime is really what? F, which is the y value, right? Okay, so we put our marks on the x-axis just like always. Okay, it's not weird yet. Okay, what happens at 0? What type of extrema? Min. So I'll put x equals 0. I have a relative min because g prime of x, which is 2f of 2x, changes negative to positive. So far, everything is the same. Now, question. When I plug 0 into 2x, does it stay a 0?
Yes.
Yes. So nothing weird happened there. Now, where does my max happen in my graph? At 2. So I have a relative max because g prime of x, which is 2f of 2x, changes plus to minus. Okay, that is wrong. Here's why. If I plug in a 2, where does it cross through the x-axis at? 2, right? Good. If I plug in a 2 to the 2x, where would I be looking at the graph? 4. Is that where it changes sign? No. So I can't pick this to be a 2 because there's already a 2 built into the equation. What x should I choose so that when I plug in here, I get a 2 in the middle? 1. Does that make sense?
Yes.
Okay, so 0, it ended up not really mattering because if I want 0, well 0 times 2 is still 0. But if I need the middle to come out to be a 2 so that I can be at this sign change, then I need to choose my x to be 1. Does that make sense? Okay, we're going to do it again with POIs. Mark the POI on your paper. POI is where the slope changes sign. Where does the slope change sign? Okay, at 1. Put your x. And so if my slope changes sign at 1, then I need to choose an x so that when I plug it into the 2x, I will get 1 for the final answer. What should I choose?
0.5.
1/2 or 0.5. Because what's half of 2? 1. And that's where the slope change happens. Does that make sense? Okay, so that's the one thing that's kind of weird about the chain rule ones. So let's write it out. We want x at 1/2 because g double prime, which is 4f prime of 2x, changes sign. And then remember that when I plug this 1/2 into this x spot, I'm going to get a 1 in the middle, and that's where the slope of f really changes. Okay, now there's one other thing that I should put when I write f prime. What is f prime in the graph? Okay, the slope of f. Okay, so I would make sure, go back and put that, try to remember. If you don't, you might be fine, but who knows. Okay, part F, I want average rate of change. What is average rate of change? A-rock. The normal formula is f of b minus f of a over b minus a. But I want the average rate of change of g. So what will it be? G of 1, right? Minus g of negative 2. 1 minus negative 2. And then look up at part A. We already found both of those. What was g of 1? 2. What was g of negative 2? Okay, or 8.5, either way. And then 1 minus negative 2 is 3. Good? Okay, part G. Let capital F be an antiderivative of little f, the graph shown above. Given that f of negative 1 is 3, find f of 1, then find f of negative 4. F of 1, f of negative 4. Okay, I'm going to set this one up for you, and then you're going to try to do the other one. Remember, what I want is f at what I have. What f do I have that they gave me in the question?
F of negative 1.
Okay, they told me that f of negative 1 is going to be 3. So, f of negative 1 plus the integral from negative 1 to 1 of little f of x. Okay, now think about where that comes from. If I took this f of negative 1 and minused it across, then it would be the integral a to b equals capital F of b minus capital F of a. So this is called your version b. Okay, so if you want to label it down here, so that on Monday when you take your quiz, you have it. It's capital F of B is capital F of A plus A to B F of X. Yeah, we've done this on a bunch of them. Okay, remember, this is what you want. This is what you have from what you have to what you want. Okay, so let's finish this one out. What's F of negative 1? They told you it equals what?
3.
3. And then what is the integral from negative 1 to 1?
0.
0. Why is it 0?
They cancel out.
Yeah, because you end up with this integral and then this integral, and they basically just eliminate each other. Okay? So it'd be 3. Okay, F of negative 4. Where should I start? What F did they give me?
F of negative 1.
Negative 1 plus the integral from negative 1 to negative 4. F of x dx. And remember, you keep this order. Whatever's here should be on the bottom. Whatever I want should be on the top. Now, after I write it, what do I notice about this? It's backwards, but I'll take that into account and just change the sign. Okay? So, F of negative 1 is 3. And then negative 1 to negative 4, what shape is that in the graph? Trapezoid, and it was 7.5 plus or minus if it's backwards.
Plus, because it's underneath the graph.
Plus. Because not only is my trapezoid under, look, it's under, it's also backwards. Okay? Make sense? So that one would have come out to be 10.5. Good? Okay, we have one more to do like that. Turn the page. And then hopefully we'll have time to look at the back page of your homework. Okay. Turn it. Ready? Good? Okay. So notice we have a graph of f. Okay, same as always. But now my g of x has an integral in it. And the top of the integral is not just x, it's x divided by 2. Okay, so first let's find g of 2. Then let's find g of 8. Okay, so if I want g of 2, where am I plugging 2 in for? What letter? The x. So if this is my x, and I plug in a 2 to that spot, it's the integral from 1 to 2 over 2. What is that the same as? 1. Integral 1 to 1. And what's the integral 1 to 1 of anything? 0. Now, do you notice the plus 3 at the back? It's not inside the integral, so it's not 0. It's still a plus 3. So what's 0 plus 3? 3. Okay, now let's do it for 8. So I want g of 8 equals the integral from 1 to 8 over 2. But what's that the same as? 1 to 4 of f of t dt plus 3. So I did 1 to 8, but 8 was divided by 2. That's where the 4 came from. And then from 1 to 4, what shape are we shading on our graph? Triangle. 1/2 base times height. How long is the base? Yay, no one said 4. Okay, that's 3. The height is 2. 1/2, 3 times 2 is half of 6, which is 3. And then what's 3 plus the 3 in the back? 6. Okay, I have g of x. I plugged in. Now I'm going to find g prime. Remember, this is like your most important step in every single question like this. So g of x is the integral from 1 to x over 2, f of t dt plus 3. What will g prime of x be? Okay, extremely close. So I take my x over 2, I plug it in here. So now I have f of, and then x over 2 is the same as a half x, right? And then what's the derivative of a half x for chain rule?
Half.
Times a half. Only thing is you said a dx in there, but you probably meant not to put it. Now what about the plus 3? Derivative. Cancels, goes away. Yeah? Okay, so now we're going to find our g primes. So if I want g prime of 2, Then I want a half of f at a half of 2. What's going to be in the middle? A 1. What's f of 1 in the graph?
0.
And what's half times 0? 0. Now let's find it for 8. G prime of 8. Well, then I want 1/2 times f of a half of 8, which is going to be a 4. Look at your graph. What's f of 4? So that one also comes out to be 0. Okay, now take the second derivative. I'll give you a second to try it first. Okay, we have g prime. Now we want g double prime. And you're going to need to use chain rule again. So what's the derivative of f?
1/4 f prime, a half f.
Yeah, so I'll take the derivative of f is f prime. The middle stays the same. But then I have to multiply another half on the half that's already there. That's a 4th. Does that make sense? Mm-hmm. So g double prime of x is a 4th f prime. And then where will I get f prime from in the graph? That's the slope. So let's do g double prime at 2. Then we'll do g double prime at 8. 2 first. I'll have a 4th in the front. Then I'll have f prime of a half of 2. Half of 2 is 1. What's the slope of the graph at 1? Count the rise over run. DNE, because why? Cusp. Because f has cusp at 1. Okay? F has a cusp. I can't actually take the slope there. Well, then I can't multiply it by a half or a 4th. Okay, g prime of 8. I want 1/4 f prime of a half of 8, which is still 4. 4 is going to be this line segment right here. Okay, remember, your line, your slope is the same the whole time. So I just need to count the slope of that. What's the slope of that line?
1.
-1. Because it's down 1 over 1, rise over run, down 1 over 1, down 1 over 1, down 1 over 1. So I have a 4th times -1. My answer is... Make sense? Okay. Next, they asked me to write the equation of a tangent line. We haven't done that in a while. How do you write the equation of a tangent line? Okay, we need a point, and we need a slope. For the point, what am I going to plug -6 into? F or G, and how do I know? Okay, G, because it tells me, what do I want to be tangent to? G. If I wanted to be tangent to F, I'd plug into F. But I want to be tangent to G. Then I need G of -6. And how will I know G of -6? I'll plug into this guy, the original. So where will my integral go to? From 1 to where? -3. Because when I plug my -6 into my x over 2, it adjusts it to be a -3 f of t dt plus 3. Now, 1 to -3, what shape is that in the graph? Okay, semicircle. So I'm going to do pi r squared and then cut it in half. How long is my radius? 2, so I'll have 1/2 pi 2 squared. What's 2 squared? 4 pi, cut it in half. 2 pi. So that means that I'm going to have 2 pi plus 3. Is that right? Is it negative?
It's backwards and
It's below, but it's also backwards. So I'm going to keep it as a positive, but it's good to think about if it could be negative or not. So 2 pi plus 3 is going to go here as my point. Then what's the second thing that I need? Okay, the slope of my tangent line, which would be G prime. And then remember, for G prime, I'm plugging back into this one. So it would be 1/2 f of a half of -6, which is -3. Then look at your graph at -3. What's my y value? -3, my y value is 0. Okay, so I go to write the equation of my tangent line. Y minus 2 pi plus 3. 0, x plus 6. Okay, that is incorrect. Why is it incorrect? Okay, the 2 pi plus 3, either you put it in parentheses, which is how I'm going to fix it, or could you give the 2 pi and the 3 each their own minus? Sure. But make sure you have to apply the negative. You're subtracting that whole thing. Or put parentheses and then it's fine. Now, the other class was like, can I just put 0 on the other side? Sure. Okay, you don't have to put the x plus 6 because you know multiplying by 0, it will cancel it out. Okay? Alright, C is where it gets a little bit tricky, but we can do it. Okay, we want relative extremums. Okay, remember that means mins and maxes. Okay, so look at your graph, put dots on the x-axis everywhere that you would have a min or a max. How many of them are there? 3. One of them's at negative 3. What type is that? Okay, that's a max. What type is 1? And then what type is 4? Okay, now remember, I cannot use those x values because what's going to happen when I find the maxes and mins? I'm going to have to plug them into what? 1/2 x. So if I want my max to be at negative 3, what would I need to plug into the middle so it comes out to be a negative 3? Negative 6. Get it? Yeah? Okay, so one more time. If I want negative 3, I have to pick negative 6. So that when I plug negative 6 in with the half, it gives me negative 3 at the end. My other max is a 4. What x should I pick? 8. So that when I cut it in half, what am I going to get? 4. And that's where it changes sign on the graph. So, I'll say I want relative maxes at x equals negative 6 and 8 because g prime of x, which is a half f of a half x, changes from plus to minus. But remember, I'm choosing the negative 6 and the 8 so that when I cut them in half, I'll be at the right place on the graph. Where will I say I have a relative min if it happens at 1? 2. Because g prime, which is a half x of a half x, changes negative to positive. Make sense? Okay, mark your points of inflection. Points of inflection are going to happen when the slope changes sign. How many times or how many places does the slope change direction? Okay, 2 is correct. Where's the first one? Okay, at negative 1, my slope goes from down to up. And then where does it change again? At 2. But remember, I can't actually pick those x's because they're going to get cut in half. So if I want negative 1, what x am I going to pick? Negative 2, because what's half of negative 2? Negative 1, which is what I want. This one I want a 2, what am I going to pick? 4. Get it? Yeah. Okay, so x equals negative 2 and positive 4 because g double prime of x, which is a 4th f prime of a half x, changes sign. And then I'm going to go back and mark. How do I know what f prime is?
Aren't you supposed to write slope of f?
Yeah, I'm going to put it right here. Okay, remember, f prime is the slope of f.
Also, you can just erase.
Yeah, I know, and this is why what I don't want to do for this one, you know how normally I put like comma, the slope of f?
Yeah.
What you would technically have to do if you were going to write it like that is a 4th the slope of f. And that's why I'm kind of like underlining only that part and marking it as the slope. So that it's not like as much writing. Okay? Now, this question actually asks you for any point that the second derivative is 0 or undefined. So I have points of inflection at the values that I listed. That says POI. Are there any other places on the graph that my G double prime would be undefined? The cusp, and there's one more place.
Oh, it's straight, because it's straight.
Yes, where is it straight up and down? -3. What type of line is it then? Vertical. And what's the slope of a vertical line? Undefined. So there are two other places that your second derivative is undefined here, but is there a slope change? Downhill to downhill. So is it a point of inflection? No, but it still counts as an undefined G double prime. And then also here. But my slope goes from up to up. So those don't count, but they still need to be listed. Okay? So let's list those down here in part D. Almost done. Now, if the slope change or the vertical line happens at -3, what should I pick? -6. I'm going to list them one at a time. So x equals 6. G double prime is undefined because F has a vertical slope, but no sign change. And then the other one we said would come at 1, which means we're going to list 2. G double prime is DNE because F has a cusp, but no sign change. So I'm basically acknowledging that both of these places, the second derivative also doesn't exist, but because there was not a slope change at those points, they don't count as POIs. Now, if it didn't say find any values, I wouldn't have had to do this. But since it says to find all of them and then determine if they're POIs, that's why we had to do it there. Okay, last part, part E. Set up your version B. Find f of 5 first, then find f of -3 second. Then I'll remind you at the very bottom of the page what version B is. F of B equals f of A integral A to B little f. So we want capital F at 5. What capital F do we have? We have it at 1. Then we'll have to add the integral from 1 to 5 of little f. Capital F of 1 is how much, they told us? 6. And then the integral from 1 to 5, I'm just going to look up at my graph, find the area. Now, someone in the other class was like, oh wait, don't forget the +3. Question, do I need to include the +3 if I'm integrating f? No. Where was the +3? In G. So if they were asking me to find G, I'd have to include the little +3. But because I'm just integrating f with a version B, I don't have to worry about that. Okay? So I have this extra little triangle that I have to include from 1 to 5. We already know this area came out to be 3. But how big is the little baby at the bottom? 0.5. So if this is 3 and this is 0.5, do I put 3.5? 2.5. Yeah, the other class was wanting to add the 3 to the back, but you don't add the 3 because that's if I was doing G. G is the thing that has like the little +3 built into it at the back. So since I'm just integrating f, I'm only looking at this graph. I'm not worried about what else G has in it, like the half or any of that.
So we're doing like anti-derivatives.
If you're doing version B, pretty much. Because what are you integrating in version B? If I want capital F, I'm integrating little f. That never had a +3 in it. No. Okay, last one, f of -3. I would start at f of 1. integral 1 to negative 3 f of x. And then notice that you have to follow the order of have to want. So if negative 3 is on the top, this integral is backwards. From 1 to negative 3, what shape is it? Semicircle. The area was 2 pi, but I'm going to add it because why?
It's backwards.
It's below and backwards. What? Oh, don't do that. Okay, good? Okay. Wow, we finished that really fast. Okay, homework questions? Anything? Okay, the very back page you need a calculator for, so I would probably recommend we just run through it. So come grab a calculator if you don't have your own. Yes, Anusha?
Okay,
2.5 was the big triangle 3 minus the little half at the back. Because it's from 1 to 5, so you have to include the little triangle. Yeah. Okay, so we're looking at the back page of your homework. If you're using my calculator, okay, my pre-cal class might have switched it to degree mode. They have a quiz today. So double check that before you start. And let's do number 9. Okay. So this is the back of homework 11, which is due on Monday when you take your quiz.
Wait, does 10 also need a calculator?
Yeah, the whole back page. Okay, take a look at number 9. You have a velocity equation. You need to find velocity at 3. What are you going to do?
B is 3.
Okay, perfect.
0 to 6.
Okay, so if we want velocity at 3, we're going to plug 3 into velocity, which is already an integral. The equation is an integral. What will I integrate till?
6.
0 to 6, sine 3t plus 2. And then where does this go if it's a calculator question?
In the calculator.
In the calculator. Okay?
I use plus 2.
Okay, my mode is in radian mode. Double checks that. Okay, then math 9 remembers the integral, 0 to 6, sine of 3x, and then just plus 2. Oh wait, hold on, this is wrong. What do I need to fix?
Put the 2 on the outside.
Yeah, I gotta make sure to put parentheses there. Okay? So, integral 0 to 6, 3x plus 2. Type it in, bam, answer. Okay? Now, remember, when I integrate velocity, what does that tell me about the particle? If I integrate it, though, that would be displacement. Change in position.
Bam.
Okay, next part. I want to know the acceleration at 6. How do I find acceleration if I have velocity? A derivative. But what happens when I take the derivative of an integral? I plug in the 2x, remember? So when I want acceleration, I have to take the derivative of velocity. But velocity has an integral. When I take the derivative of an integral, I just bloop, bloop, plug the 2x in. So now it's sine of 6x. Okay, no, because remember, the derivative and the integral cancel out, and you just plug this in. Now, is there anything else that we're missing? Oh, oops, it should be a 6x. What else, though?
6x squared or something?
Let's see.
No, times 2. Chain rule, right? When I take my 2x and I plug it in, and this is a 6x.
2 sine 6x plus 2.
Yes. Okay, this is the chain rule. Okay, I take the 2x, I sub it in where the 3 is, so now it's a 6x, but then I have to remember to multiply by 2, and then where do I want the acceleration at? 6. So then what do? Just type that into my calculator. Yeah? So it will be 2 parentheses.
Should be gone. Why plus 2?
Okay, here's why. Remember, for fundamental theorem, when you take the derivative of the integral, you are subbing the endpoint in, but keeping the equation the same. Because I would have done the antiderivative, which would have made that a 2x, and then taken the derivative and turned it back into just a 2. So remember, the derivative and the integral cancel each other out. Think about a 2. If I do the antiderivative, it's a 2x. Then I take the derivative of it, now it's a 2 again. So everything in the equation stays the same except the substitution and then the times chain rule. Okay? So in the calculator, it came out to be 2.0164. Now, if this is measured in meters per second, what would the acceleration be measured in? Good job. Yep. Yes, you're right.
So, did you plug 6 into 6 sine 6x?
Yes.
So like sine 36?
Yes. So look, this is my acceleration, a of t. And then this is my a of 6. And I just plugged it in right there. So if you look at my calculator, I literally just typed in 6 times 6 in the middle is a 36. Good?
Yeah.
Okay, last part. Acceleration is the derivative. What is the average acceleration? It's still a derivative, but it's an average derivative, which is... Yay! You learned some things. I'm so proud of you.
So you see on how it says particles after the number, it says acceleration. I was thinking particle.
Yeah. Okay, so what's V of 3? We found it in part A.
12.1132.
Okay, then when I plug in 0, I want you to just think about, if I found V of 0, what would my integral be?
0 to 0.
0 to 0, which is just 0. So you can type it into the calculator if you want, but we already know it's 0. That's good enough. Now, if I did acceleration, I get meters per second squared. Average acceleration is the same thing. Okay, the only difference is this is the acceleration at 6. This is the acceleration average over 3 seconds. Okay? You can, but you don't have to.
So why is it 0 if you get a plus 2?
Why is what?
Why is it 0 if you get a plus 2?
Because remember, the plus 2 is inside the integral.
Sorry.
So if I do the integral from 0 to 0 of sine 3t plus 2, do you see what I'm saying? That 2 is inside the integral. So that's why it ends up zeroing out. Okay? Okay, we have just enough time for the last one, and then you can just work the rest of the class. Okay, last one. Velocity is here. You want average velocity, then you want average acceleration. There are 2 averages, A-rock and average value. Which one is part A, A-rock or average value?
Average value.
Value, because why? The units stay the same. Okay, if this is velocity and I want average velocity, that is the same units. So it should be average value, which is 1 over b minus a, integral a to b of v of t. Now, I'm going to just go all the way through the question, then you can just type them all in at the end. Okay, what will I do for average acceleration?
A-rock.
That will be a-rock, which is v of 4 minus v of 0 over 4 minus 0. Okay? But notice the difference. A-rock, rate of change, is a derivative, and it's acceleration because I have velocity. Okay, part C. Particles' position at time 5 is 2 to the left of the origin. What did they just give me? The position x at 5 is 2 to the left. What's the position? Okay, they just gave me that. That's a negative 2.
That's a weird.
Okay, then what are they asking me to find?
G at 12.
Okay, now let's be careful. Position at 12. So I want to find x of 12. This is a version B. What do I want?
12.
X of 12. What do I have?
That's a 5.
X of 5 plus the integral from what I have to what I want. Okay, and remember that if these are capital F's and that's a little f, then if these are position, it makes sense that would be a v, because this is the antiderivative of velocity. Okay, then from there, what's x of 5? Negative 2 plus, then you would type that into your calculator. Okay, if you want to see what it looks like, it would look like this. Negative 2 plus math 9, 5 to 12. And then I would just type in my function, x minus 2 sine x dx.
X minus 2.
It's in the equation right here.
Oh.
Yeah. Okay, and it comes out to be negative 9. So the position at 12 would be negative 9.
Isn't it plus?
Plus negative sign?
Yeah. It's negative 2 plus negative 9. Oh, yeah.
Oh, so I typed the negative 2 into the calculator. So got you. Okay, you got it? Nope.
Yeah, how do we do the language?
Okay, how do you find when something changes direction if you have velocity?
PP!
Okay, it changes PP. What's a PP? No, you find where it crosses the x-axis. Okay, so it would be those 2 points right there. Okay, so I'll just sketch the graph. It's here. It goes, whoop. So 1, 2, 3. Those are your direction changes. Those are my. Okay, so you just find those values. Now keep in mind, it's your homework. If you know how to find them, then great. That's what I want. Okay?
Wait, I'm sure I've got it.
So, like,
I can't see what's going on. Come on.
Why do you what?
why we kept the 2, right? But then on the notes, we did.
Okay, that's a great question. Here's why. Here, the plus 3 is not part of the derivative, or the integral. So when I do the integral, it's plus 3 after. This one is the integral, including the 2, and then the dt. So if you want, let me put parentheses around this. Does that make sense? So when I plug in, I'm plugging into the middle, well then the 2 stays, versus here, when I'm plugging in this here, the integral's over at the dt, and then the plus 3, the derivative of that is 0. You're welcome.